Yeah, I see that.
Oh, perfect. Okay, then I'll just go ahead. So Kevin actually did an amazing job and planned this meetup like half a year in advance. So I was actually planning to be in Sheffield and York this week, and I'm actually a bit disappointed that I cannot enjoy like the amazing weather that we have and maybe a pint after the sessions. But I hope to chat to you afterwards in the virtual bar at least. So today I'm going to talk about cloud management, cloud infrastructure, cloud provisioning, basically how we can put our applications and run them in the cloud, sort of in a new way that I suggest. And I'll start with a personal story. So I'm actually not that involved into infrastructure, or at least I haven't been involved in infrastructure for many, many years. I'm just an application developer. I've been doing .NET for like 15 years or so. And probably the first time I started caring about where my application actually runs is about 4 or 5 years ago, when we worked in a small company and I was sort of leading some application development. And finally, I realized that in order to make sure that my applications are running great and like performing well and resilient enough, I need to understand where they are and like what is the hardware behind them. And back then, we were running all the applications on our own data centers, so our own servers somewhere. And we had a small team of several developers and also IT people, and we worked in like DevOps fashion where we meet each other every day and discuss what's going on in production. I knew how our deployment works, like what are the servers behind, how to roll out a new version, like what happens if something fails. I was on call. I could wake up in the night and go fix something in production. Then about 3 years ago, maybe 2.5, we started to migrate our applications one by one from on-premises to the cloud, and that was Azure cloud. So basically, we took our legacy portfolio and like started moving them one by one to Azure infrastructure. And the cloud is amazing. I mean, there are dozens of services we wanted to use immediately, like 6 or 7 of them. And what I found is multiple things. First, that because you want to use multiple services at the same time and you want to deploy more granular components, so you end up with much more components to manage suddenly. Instead of just web servers and databases, we started to have managed queues, managed storage, managed databases, app services, and so on and so forth. And second, we could finally automate everything. So we already had unit tests, we had some end-to-end tests, and finally we could automate infrastructure provisioning. So we created a bunch of templates and PowerShell scripts so that the new environment could be provisioned with basically one button click. And that's great, but the process of creating that definition or infrastructure as code, or other infrastructure as JSON templates, because we were using ARM templates, was quite painful for me personally. I remember that just for one application, we wrote about 5,000 lines of JSON to describe the infrastructure. And that application wasn't like doing any rocket science or whatever. It's just web layers, some queues, some background workers, some databases. And the process of writing that JSON was also painful. You usually just find a snippet somewhere in Stack Overflow or on GitHub, copy it to your project. You cannot validate it. You just run it on test environment, wait for 5 minutes until it completes, and it yells at you with some error. Then you try to fix it and repeat again, and so on and so forth. So the process was quite painful. And comparing to my usual developer experience, I thought that actually there must be a better way to do this. Around 2 years ago, I found a tool that I'm going to talk about today called Pulumi. And the idea was that you use general purpose programming language. Back then it was TypeScript, but now we can also use C# or any other .NET language as well. And you, instead of using JSON templates, you use all the tools that you're used to as a developer and start deploying infrastructure with those tools. So I was so excited about this tool, I started using it on my personal projects. And actually finally, like half a year ago, I joined the company, and I'm now working as a developer developing this Pulumi tool to deploy cloud applications. So a bit more formally about myself, I'm a software engineer at Pulumi. We are a small company of like 20 people. So I work on many things, but my main specialization are .NET SDK, so supporting .NET developers, and Azure, obviously. Like my additional biases are towards serverless applications, so something like Azure Functions, AWS Lambda, and the functional programming in F#. So my examples today, a lot of them are going to be about Azure Functions, and not that much of Sharp, unfortunately, because I assume you are mostly C# developers, but I'll have at least one slide. So if you have questions after the session, you can ask them live, but also if you have a question tomorrow or next week or whatever, reach out to me on Twitter at Mikhail Shilkov and email mikhail@pulumi.com. So the agenda is pretty simple. I'll give a short introduction to the tool. I'll make a demo to make sure that you understand how it works and what's the idea. And then we have this funny theme about superpowers. So we have a mascot, like I show on this slide. It's like platypus, Australian weird animal. And we gave him some superpowers. So we have just present our capability as superpower of cloud provisioning, just to make it a little bit more fun. So I'll go through that list, show you how it improves your provisioning architecture, testing, and delivery throughout the slides. But first, what Pulumi actually does. Well, the idea is that you can use general purpose programming languages to describe your infrastructure. And it's not just .NET. At the moment, we support 4 runtimes. So Node.js with JavaScript or TypeScript, Python, Go, and .NET Core, any .NET language, C#, F#, Visual Basic. And the tool is fundamentally multi-language. So every capability more or less appears on all runtimes, hopefully more or less at the same time. Of course, there are exceptions, but that's the goal. And then you can use those languages to provision infrastructure in multiple clouds. So we are not Azure specific or AWS specific or anything. We support a model based on providers. So any cloud can be a provider in Pulumi, and you can manage resources from multiple clouds, even from the same program if you want to. And beyond just clouds like AWS, Azure, and GCP, we also support not exactly clouds, but providers for some other tools like Kubernetes. You can deploy to Kubernetes resources from the programs, or even things like Postgres database or New Relic or Datadog. So the idea is that you have multiple layers in your application, like you deploy maybe networking, some compute cluster, maybe you deploy Docker images to the registries, then you start moving your applications to Kubernetes and adding some monitoring with Datadog. And you can do all of those things from one set of tools or even from one program, if that makes sense to you. So without further ado, I want to jump to a demo, like first main demo of the day. I'm going to go ahead and deploy from scratch a new static website. So put some files into AWS. So I'm in a new folder. It's empty right now. So I have Pulumi tool installed. That's just a tool that you install on your machine. Works on Mac OS, Windows, Linux, anywhere. And then I say I want to Pulumi new project. And then because I'm doing AWS with C#, it's called, the template is called AWS C#. So I just hit that command. And what it does, it downloads the files from like template repository, asks me several questions that I just take all the defaults. And it will bootstrap a project for me. And we'll put C# files and some configuration on my local folder. So now if I list this, I have some files here, and actually go ahead and open this in Rider IDE. So you can use Visual Studio, you can use VS Code if you want. Let's make it new window. But that's basically just the C# project that was created on my disk. When it loads, I will show you the files which are there. So it's a C# project. Oh, no, I don't want this. Okay. if I just open the C# project itself, you can see that it's a .NET Core console application. And there is just one NuGet package reference here, which is pulumi.aws. That's what I need for my program. And then there are two C# files here. One is program.cs, that's the console application that I have. It's very, very simple, just one line. We have a main method here. All it does, it calls our Pulumi class called deployment and calls run async on it, and passes a generic class name, mystack. And mystack is where all the code actually lives. So it's very simple here. If you want to do something smart here instead, it's just a console application. If you want to read like a config file or even make remote calls or whatnot, you can do it here. But in the end, you have to call deployment run async and pass your stack. And then the most important file here is my stack. I'll just go into clean it up. This came from the template, but I don't want this. It's a class which is derived from Pulumi stack. And a stack is like a container for all the resources that we want to deploy together at a single time. So if you want to deploy a static website, I need to define all the resources for a static website inside this class. And I go ahead and I go to the constructor. I have some shortcodes to avoid typing too much. So the first snippet I have here creates an S3 bucket. You can see that that's just a constructor call. So I create a new object called bucket by creating an object of type bucket and passing a bunch of parameters here. It's just the name of the bucket. And then I want to make it a website. So I say, hey, this is a website with index document called index.html. Then what I need to do next is to basically start searching for files that I already have on my disk. And I prepared the root folder one level up with two files, index and about.html. So I want to deploy two files on my disk. But this is to illustrate that I actually can do any C# code that I want here. So I can bring up extra NuGet packages. I can use standard libraries. In this case, I'm using directory class and get files to list the contents of my file. And this kind of things are very complicated if you use something like JSON templates, because you don't have the full power of the language and the standard library here. So I have a for each loop which iterates in the file, and for every file, I want to create a bucket object. So I take the name of that file, and then again instantiate an object inside the loop, giving it a name, and then a bunch of parameters. It says that that's a public file in this bucket that I created above, and it's an HTML file, and I point to that file with source property. By using the bucket object here, the tool is going to be smart enough to understand the dependency between the two objects. So it knows that it has to deploy bucket before deploying any bucket objects into that bucket, just because I used the variable in the definition of the second object. And finally, the last snippet, because I don't know the URL of the website that Amazon is going to create for me, I need to export it from my program. So my last step is to take the bucket that I got and then use its output property called website endpoint to assign this value to the output of my stack. And I define the output as a property and assign a value to that property in the end of my constructor. And that's basically the whole program that I need to create to deploy a static website. Now, if I were to run this program just from my IDE, nothing would happen. In order to deploy these resources, I need to go back to the CLI, which is hopefully somewhere. Yes. And now with my program, I need to type another Pulumi command, Pulumi up or Pulumi update. And it will go ahead and it will compile my program. It will also run my program. And the result of the execution of my program is going to be the description of the resources that are about to be created. So they are not created yet. The CLI just shows me the preview of what's about to happen. It says that it's going to create 4 resources. Well, the first one is just stack. That's like a virtual resource. It's nothing in AWS itself. But there are also 3 real resources, 1 bucket and 2 bucket objects. And I look at this preview. I can say, yeah, okay, that's what I expect. it looks great. So if I hit yes, this time it will run the program again, but it will actually start creating resources in AWS. So the program runs again, it computes the same set of resources, and then because the bucket was the first one, because other objects depend on it, it goes ahead and creates a bucket, and then after a bucket is created, it creates 2 bucket objects. And the result of the execution is that endpoint that I defined as a property, and that's the URL of my website. If I click it, I should hopefully go, yes. So that's the URL on the website in AWS, and it returns the contents of my index.html file. So the deployment worked. Now to make it a little bit more interesting, let's go back to the program and change it. So I know that we have in our account a cleanup script running. So if my bucket doesn't have a tag on it, which says who is the owner of that bucket, it's gonna clean up that bucket like during the night. If I don't want to avoid this, I have to assign a tag to my bucket. And I do this just by typing another property in the program, and you can see that I'm using like IntelliSense, all the help from IDE. If I make a typo somewhere, I will get red squigglies or red font, so I can immediately iterate on the code and at least make sure that its shape is valid and it does more or less what I expect. So I change the program. Now I switch back to the CLI, and I'll type Pulumi up again. This time it runs the program again, but now it knows that the resources are already deployed. So it will compare the state of the previous deployment to the new state of my program, and will show me the preview of what's going to happen if I hit yes again. So it detected that there is an update here, that the differences is tags over here, and it also doesn't really know whether AWS is going to change the URL of my website. Like in practice, this will not happen in this case, but it could change the URL. So it says that endpoint might change from something existing to something that it doesn't know yet. And if I'm happy with this, I can click yes again. And this time, the only thing that will happen in AWS is that it will update the bucket in place without touching my files. So you can imagine if you have the deployment of like 50 files or like 50 resources, maybe 3 of them changed. So that's going to be the exact change that you will see in the preview, and also the exact change that will deploy. So this is done. I'm not going to show you that tags are actually updated. That's basically the idea of the CLI. One final thing I want to run to, not to forget this, to do this later. I want to destroy all my resources. I type Pulumi destroy, and now it basically compares my previous state with the new state of empty resource and says, this is your difference that I'm going to apply now. If you want to go ahead with the destruction, I will delete those 4 resources. And if you ever try to clean up your AWS account, you will appreciate this command, because finding all the existing resources in AWS is pretty painful. Yes, so everything is deleted and my account is clean again. So I'm go ahead and switch back to the slides. So hopefully that gives you an idea about what's the workflow of working with Pulumi. Now, a little bit to step back and give you some theory about how all this works. Yes. So first of all, every cloud is amazing because they have API for every resource. Every time you need to deploy something, there is always some endpoint in the cloud that you can just call, wait a little bit, several seconds or maybe several minutes, and then get back the credentials or like the ID of the new resource that you just created. Every cloud has this, like in Azure, it's called Azure Resource Manager API. AWS doesn't have like a single layer of API, but every service has API to create resources. And that's the API that every tool that provisions resources in the cloud is going to use, whether it's just a web portal, web console that you click the buttons around, whether it's a CLI, command line interface, some third-party tool like Pulumi, they all in the end call the API. But the way they call API in the developer experience they provide are different. Now, every cloud also provides a bunch of SDKs with their cloud. So Azure, AWS, this is an example for AWS. They ship SDKs for the most popular runtimes, including .NET. And you can take this runtime and start creating resources with that SDK. Now, a couple slides later, I'm going to explain the biggest difference between this SDKs and Pulumi SDKs and how the workflow is completely different. But that's one option to create resources in the cloud. If you are more of an IT person, you probably use the command line tools a lot, something like AWS or AZ. Pretty much the same thing. Every time you call a command there, it goes ahead and calls that API in the cloud. Now, the challenges of these SDKs and scripts are that they are very imperative, so you have to describe the provision process exactly in steps. And also, if you are not creating a new infrastructure environment, but you are updating the existing one, you have to describe how your update process should work. So over time, you end up with a lot of scripts that move your state from n to n+2. If you need to create a new environment, you have to sort of run them all, or you have to keep 2 copies, one creating a new one updating the existing one. And that's also quite error prone. So if you wrote a script and then it fails in the middle, you already created a bunch of resources, but maybe you cannot run it again because you will create duplicates, so it will fail with a new error, and you usually don't know what the current state of your environment is. So that's process of using SDKs or scripts is quite painful and like error prone and manual. So instead of doing that, the industry quite a long time ago came up with the notion of desired state configuration. And the idea is that instead of describing the steps how to get to what you want, you just describe the target state of your infrastructure. So the ideal state, the goal state that you want to get from the cloud. And then there is some tool which knows how to compare your current state of the infrastructure with your target state, and then figure out all the nitty-gritty steps to bring one to the other. And if your environment is new, it will create all the resources. If it's exactly the same as your target, it will do nothing, and everything in between. You evolve and you change only your desired state configuration, and then you can put that state into your source control, track its history, and it gives a lot of benefits. A useful way to look at this desired state is actually to think about graphs of resources, where target state is a graph, current state is a graph, and they are different. And every node in the graph is one resource, and every edge in the graph or arrow on this chart is a dependency. And dependencies are crucial because you need to know dependencies in order to figure out the right order of creation, deletion, or the replacement of resources. And every tool has to figure out this on their own. So coming back to Pulumi, that's a simple snippet of a C# program here, which defines 2 resources. And the most crucial thing to understand about this code before you even start coding with Pulumi is that this code is desired state configuration. So it does not translate immediately to commands to the cloud, as I explained before. So when the first line is executed, there is no command going on to Azure. The result of this program is actually the definition of the graph, like which resources are about to be created or updated, like what are the dependencies between them. And that's why you need the CLI that I showed before that would take this graph definition from .NET program and then compare it to the previous state of the deployment and figure out the next steps. So if I show this a little bit on the picture, there are multiple components to make this whole setup work. First, at the bottom is your program, like say program.cs or mystack.cs, doesn't matter. And there is a language host which is specific for .NET in this case. It knows how to compile the program, how to run this program with .NET. And the result of the execution of this program is a bunch of calls of new resource that go to the CLI and to the engine. The engine is that program that I installed on my machine called Pulumi. It gets the definition of the graph, and then it compares it to the previous state of the deployment. In my first demo, the first state was empty. The next state had 3 resources already. So it compares the desired state to that state and figures out the steps. And only then, when I confirm that I want to deploy with yes, only then it issues the CRUD commands to AWS or Azure or GCP or whatnot to create resources via providers. So we have a provider per cloud, and provider is actually relatively dumb thing. It knows how to create something, update something, or delete something. It doesn't know about any dependencies, about any orders, or like what changed, doesn't want to compare anything. It's relatively straightforward. That's why we can create a lot of them. Okay, so of course, the desired state notion is not new. Maybe you are familiar with one of those tools like AWS CloudFormation, Azure RM templates, Terraform maybe. All of those are desired state configuration tools for cloud deployments. The first two are specific to their cloud, and Terraform is across cloud. What's common about them is that all of these tools use markup languages to describe your configuration. YAML, JSON, or Terraform has their own language. This is all basically text files that you describe, which is nice in the sense that you can read them relatively easy while they are small, but they bring a bunch of downsides as well. So first, the tooling sort of doesn't exist when they just start. It's just a text file or just a JSON or YAML. They cannot give you IntelliSense and so on. So now every tool starts to invent, every like tool of those starts to invent their own plugins for IDEs or for VS Code that would help you discover something. But they are all still raw. Like if you ever try to use plugin for Terraform, you will see that it's still pretty painful, far from what we are used to with Visual Studio. Then creating these templates from scratch is pretty hard. Usually you end up finding existing examples and copy pasting large chunks of those, just because writing them is not that easy. And as I alluded to already in my introduction, the sheer size of those templates grows very fast. Like they are very low level. You always sort of map your resources to your JSON or YAML files one-on-one. There is no way to abstract things in a nice way. So you just create new resources over and over and over. Just a quick example, I created an application, or rather I found several implementations of that application. Very simple application called URL shortener. So something like bit.ly or tinyurl.com, where you go to a URL with a short alias, and then it redirects you to a full URL that is saved in its database. And I implemented it with serverless functions, Azure functions or AWS Lambda. And the amount of code that I needed to write it is actually very low. It's like 20 lines of code. Just read and enter it from database and redirect the response. But in order to deploy all the infrastructure, you need, say, AWS Lambda, API gateways, permissions, DynamoDB. You need to connect all of this. So it ends up like 200 lines of code for CloudFormation, ARM templates, or Terraform. It doesn't matter, more or less. So I write 10 times more, order of magnitude more infrastructure, markup code than application code. And that doesn't really seem right to me when I look at this. I don't want to be writing markup code. I want to be focused on my application. So just in a second, I'm going to show you how it looks like with Pulumi. But first, as I mentioned already, you can use all the .NET tools that I used to. So when you open your IDE and you start coding your programs, you use all the goodness of .NET Core 3.1. You can run on any operating system, use any language that you prefer, any IDE that you prefer, because it's just a .NET project. Whatever can compile or create those projects is good enough. And then you get IntelliSense, you can refactor with ReSharper, or things like that. You can lint with StyleCop. You can get docs with Dockerfix, all the package managers that you're used to. And also you can use things like unit testing. And I'm going to show you an example later in the presentation. So all the tooling that you are used to and that you love, you can reuse for infrastructure definition. Now, this is just to allude to all the languages, like we support C#, that's the same code in C# that I showed before, that creates the storage account and the service plan. And then, oops, that was too fast. The same kind of code applies to other languages. So if you are more of a sharp person like myself, you can write a sharp code. It's still the same idea. You call object constructors to construct the tree of resources and pass one value to another constructor just to create dependencies between them. Maybe you are a VB.NET developer. Honestly, I did not meet anyone using Pulumi with VB.NET yet, but maybe you will be the first one, so you can use also VB.NET to define cloud infrastructure. Now, how does this impact the architecture of cloud applications? How does it solve the verbosity of infrastructure definition? Well, let's take an example of Azure Functions. So if you want to deploy a function app, a simple HTTP endpoint or a queue processor, you actually need to create 5 resources in Azure. That's a function app itself. Then you need to create a consumption plan or app service plan to host it. Then you also need a storage account because it's required for the function of the function app. And also, if you deploy via storage account, then you need to create a storage container and storage blob to put your binaries in that blob. And all of this also lives in the resource group. So actually, 6 resources that you need to create. Now, instead of copy-pasting these 5 resources every time, what I can do is to create a C# component that would abstract away that structure from me. So that's what I did in this example. There is a component called archive function app. Like, it doesn't exist built in Azure. That's a component that I create. That's just a class in C#. And that class knows that it needs to create those 5 resources with the right properties to deploy my application. But I only care about my functions, actually. So the only properties that I have to fill for this component are resource group that I want to put it in, and then point it to a folder on my disk which contains the binaries for the function app. And that's it. So I can make my component once, then I can make, say, a NuGet library to share it with my colleagues or even with broad community. And every user is going to have much smoother experience creating that function apps without even thinking too much about what exactly it takes to deploy the function app. And when I run this program, this exact program with Pulumi, I will get the same preview, and it will show you that, yes, there is a resource group here, but also there is a virtual component archive function app that contains 5 other components. So I still need to sort of understand what I'm doing and what kind of resources are created in Azure, but I don't have to codify this again and again in every program where I need Azure Functions. Now, I can also make this component as flexible as I want. So if I want to, let's say, host different languages of Azure Functions. My first example assumed it's going to be C# Azure Function, but maybe I want to host a Node.js Azure Function. So I write something in JavaScript. I change the archive property to the new folder, obviously, but also I use the next property called runtime, and I said that that's a node. And now my component has to know how to take care of that property and like set the right application setting on the function app. But me as a user of that component, I don't have to care about this anymore. I just need to be aware of this possibility and like set up my component to run the Node.js application. Maybe if I want to run the Python application of Azure Functions instead, there is one more configuration that I have to take. That's because the Python applications only run on Linux in the Azure Functions, and my default is Windows. So instead of running on Windows, I actually have to define manually an app service plan that would say kind Linux and so on and so forth, all the right properties for that plan that I want to create. Again, I only define the piece of infrastructure which is specific for my use case, but then I can pass this plan as yet another property to the archive function app component that I created. And it's still manageable. Still, I care about one extra bit of configuration. But now I say it's a plan on Linux, it's runtime Python, and that's all that is required to start deploying the application. Also, it doesn't have to be just that simple of abstraction. It may also make sense only for my team. So let's look at another example. Let's say I'm working on like an e-commerce website, Amazon competitor or whatnot. And my users are worldwide, so I want to deploy my applications close to the users so that customer experience is great and latency is low and so on and so forth. And I deploy this to Azure. So if my customers are in the US, Europe, and Asia at the same time, I probably want to deploy 3 regions to keep my bits close to the user. So I might use Cosmos DB replication to like scale out to all those regions and put data close to each other. That's great. That's a great service. I can leverage that one. But if I want to use Azure functions, they always deploy it into one region. So instead of just using one application, now I have to deploy 3 applications. And then I need some front-end load balancing service like traffic manager or front door. And I need to link it to every region and explain it how to route users to the nearest one and link every function up to the Cosmos DB replica and so on and so forth. Maybe do some networking. So you can see how this becomes really, really complicated quite fast. And the more regions I have, the more components to manage. Now, maybe I work on a product page, but my another team works on like shopping cart, and they deploy to the same website, but they have a different microservice, and maybe they don't use function apps, but they use Azure container instances or whatnot. They still have that problem of being close to the user for low latency. So they have all the same challenges about distribution throughout multiple regions, but their setup is slightly different. And maybe a third team, they use some legacy JVM application, I don't know. They only can deploy to virtual machines, so they have to provision VNets, subnets, scale sets, load balancers, public IPs, and do it in every region, and then connect to load balancers and Cosmos DB replicas. So they have to take a lot of complexity, but also a lot of that complexity is similar to my use case. So the 3 teams of ours, can actually sit down, talk to each other, and find that there is a common pattern for us. And then maybe we can codify this pattern as a component, make it once, and then reuse it across the teams. It cannot encode like all the resources that we have, because our application layer is different. But it could make it pluggable because we are using a general purpose programming language like C#. So I did that. I created a sample component, Cosmos app, called Cosmos app. Then it does exactly what I described. Like you pass it a list of locations, in this case, 3 locations. And in addition, you pass a factory. So it's a method in C# like Lambda. It gets 2 parameters, some global configuration, some region-specific configuration. And then the goal of that callback is to create all the compute infrastructure which is specific for my use case. In this use case, I use the same archive function app to create infrastructure in just one region that the callback parameter specifies. So region location says which region it should go to. And then I return back the endpoint or the ID of my application back to the component. Now we can imagine that component has a loop inside. It will go through all the locations and call my callback once for every location, get back the ID, and then wire that ID with both Cosmos DB and the load balancing service. So we can reuse part of the layout and like reuse that multi-region layout between the teams, but different team will have container instances provisioned here, or they will have VMs provisioned here, and I will have function apps provisioned here. And we can take this component, we can put it into our NuGet repository. We can share it. We can apply semantic versioning. We can unit test it forever, like until it's perfect, and take all the advantages of the tools that we already use and love. So a quick word about testing. So because we use C#, we can apply unit testing to it. Instead of deploying the components to the cloud, waiting until it finishes and like running end-to-end tests on it, we can mock everything about the cloud and run everything in memory. You remember that the result of the execution of my program is the description of the graph of resources. So we, as Pulumi, provide a helper method called test async. You remember we used to run async to deploy, now it's test async. And all it does, it executes the program, it doesn't deploy anything, but it deploys the graph of those resources back. And now I can inspect that graph and start making assertions about its shape. In this example, that's an AWS example. And we want to make sure that whatever we provision in that stack, there are no SSH ports open to the public. So I have a test. I can use any unit, X unit, whatever I want. I call test async. Then I find all the security groups in that stack, or this, well, in this example, I find one security group, but it could be all the security groups. Then I get ingress rules of that security group. I iterate through the ingress rules and check every rule. If there is a CIDR block there, then I check if it exposes SSH port 22 to the internet. And if it does, then I fail the unit test. So I don't have to know the exact structure of my stack. I can write inspections like this and make assertions about the shape of my resources. And also it will run like instantaneously in several milliseconds. So I can run it on every code change. I can run it on every commit. I can have like 1,000 of those tests and still run them pretty fast. Of course, integration tests are still useful, but there is a limit to how many of them you can have, and like they are much less reliable. This is fully deterministic, and you can apply unit testing practices to your infrastructure code as well. So if you want to learn more, there is quite a lot that goes there. Basically, you need to mock the engine, and like you can also describe how the cloud behaves. So let's say you want to inject an error or something, you can do it with mocks by mocking the cloud engine. So there is a blog post on the Pulumi website that I wrote, which explains step by step what you can do with unit testing cloud resources. Also, unfortunately, this is still not available in .NET, but you can use TypeScript to sort of make one step forward. And instead of writing unit tests for a specific program, you can start writing policies for all the programs that your, say your company deploys. So maybe you are a security officer and you want the same effect that I described about the SSH ports, but applied to all the deployments in your company. So you can write a policy. In this case, this is TypeScript, where you do the same. You get a list of resources, and then you check if there is a CIDR block with SSH port open. But then you can deploy it once to your infrastructure, and every deployment before it starts deploying the resources, or in the middle, you can configure this. We'll check these rules, and if the rule is violated, it will be stopped and prevented from exposing your security vulnerability to the public. And again, you can sort of do this with the clouds, but they also use things like JSON configuration. It's pretty hard to codify the rules like that with arbitrary rules like that with libraries and so on without having a real programming language. So finally, a couple of words about how the actual production delivery would work. So this is the same diagram that I showed before. And I showed you the last deployed state there, but I did not describe what it is. It actually has to be stored somewhere between the deployments. By default, it will be stored in our backend service, which is always up and running, hopefully, and available to you. If you don't, like it provides some extra features like user permission management and like concurrency management, so that you don't run two updates at the same time and so on and so forth. But if, say, you don't trust our service or you have to be logged to your environment, you can also choose to put your state anywhere else. For example, a common case is to put it to like S3 or blob storage, or even like on a local disk. And then you have to take care of keeping that state between deployments. And if you lose it, basically you lost it. But then you manage it and you define where it is, and we never get access to that state as well. So to reiterate, Pulumi has multiple components. It has the command line interface, the program that you deploy to your local machine or your CI/CD pipeline. You have providers that talk to the cloud, and they are both open source, free for any use. They're on GitHub. You can go there. We take contributions, and like everything is free, and you can use for any purpose. And there is also the SaaS backend, so the state storage that I showed before, but it also, you can think of it like GitHub for your, if Pulumi CLI is your Git and SaaS backend is your GitHub, it provides you like history management, audit, control, and so on and so forth. So if you find value in this service is actually not open source and not free for large teams. So there is some cost, and that's how we plan to make money, or that's how we make money with this product. But it's optional. you don't have to use it unless you find the value in it. A bit about how deployment works. So I showed you the top row. When you are a developer, you probably run everything from your laptop. You have all the credentials configured to access AWS. You download Pulumi on your laptop and you run it, and it deploys resources directly from your laptop. Probably that's not something that you want in production. Probably you don't want to give your developers production access. So instead, you create a CI/CD pipeline, and then we have integrations with like a lot of CI/CD products. Say, pretty much any CI/CD product you can think of, there is an integration there, and all the integration does basically it stores the credentials for the cloud and then runs Pulumi CLI behind the scenes. So it gives that credentials to the CLI, and then deployment happens from your CI/CD pipeline. Okay, I'll skip this one. So the idea, the power of Pulumi also is that you can deploy multiple layers of applications. So in a second, I'm going to give you an example of Kubernetes applications. And you can think, when you think of a Kubernetes application, you need to deploy multiple layers of infrastructure. And the same applies actually to virtual machines or serverless even. You have to deploy some foundational things like networking or storage or monitoring. And on top of that, you have to deploy some compute layer from VMs to containers to serverless. And then you deploy your applications. And also, you probably use some data storage, so that also goes side by side with applications and compute layer. And the power of Pulumi is that you can manage all of those components from the same set of tools and the same set of programs. So taking a Kubernetes, for example, to deploy an application in Kubernetes, you have to deploy multiple things. First, you have to do networking, storage, and identity. Then you need to provision a managed Kubernetes cluster like EKS or AKS in the cloud. And then you probably use something like Cosmos DB for data storage. And after all of that is configured, you can start deploying multiple applications to the cluster. And the thing is that probably these layers are managed by different people in your company, like from IT people on networking to application developers on the top. And then probably also they have different life cycles. So you don't change networking as often as you deploy applications. So in fact, it's quite likely that you will want to manage all these layers from Pulumi programs, but probably you'll have multiple programs and also maybe created by different people. And that's why like the power of having multiple languages is also very useful. Maybe your IT people are going to love Python more than .NET, and your application still can use C# if you want to. So in this case, you probably will have multiple stacks. I showed you the stack already. So you'll have probably a stack for networking, a stack for cluster, and stack per application that deploys to that cluster. And then you can use something called stack references to pull data from the previous stack to the next stack. So if somebody already deployed networking, you can reference to that stack and get outputs of that stack to provision Kubernetes cluster. And then you create application stack, and then you reference the Kubernetes stack to get kubeconfig and deploy applications to Kubernetes. So just a quick show of code. I'm actually wrapping up, but that's like the last demo I want to show. So in my sample solution that I have here, I have 3 projects in here. One deploys networking and Kubernetes cluster in AKS, and 2 are imagine an application that are deployed by different teams. And cluster stack maybe it's done by IT people, and they need to provision a lot of resources that go to AKS, like create SSH keys and service principals, passwords, virtual networks, subnets. The details are not really important here, but in the end, you define a Kubernetes cluster, and what you do, finally, you export kubeconfig from the stack to be used by other stacks. And then different stack says, I want a stack reference to that AKS stack. That's the name I gave it to the cluster stack. And then it creates a connection string to that stack from that reference. And it can use those options to kubeconfig to start provisioning components in Kubernetes. In this case, I'm using some custom component again that does the service and deployment with like this container image and these replicas. And my program, again, is very short and concise, and you can really easily see what it does. And the second project, instead of defining C# classes, it deploys some YAML files as Kubernetes applications, and deploys one YAML file and one Helm chart. So that kind of alludes to a migration story. If you already use Kubernetes and you have a lot of YAML files, for example, but you want to use Pulumi to provision AKS cluster, you can still manage all the files and Helm charts and whatnot from the same set of programs and get all the benefits like preview and lifecycle management and history and so on. But you can slowly migrate your existing files and maybe start codifying them in C# later on. So that's the last demo, and just to wrap up some conclusions. So we envision the future where application developers are very much involved into infrastructure provision in the cloud. And that's because they want to be like agile and like deploy their applications as fast as possible, iterate very fast, and they have to know about the infrastructure, and they have to manage that themselves to understand it very well and to control how their application behaves. And the tools like Pulumi should simplify, should reduce that gap between IT people and developers, and sort of make provisioning less scary, more reliable, more testable, more easier to apply things like abstractions and create custom logics, and create reusable components and ecosystems and things like that. So that's why we think using general purpose programming languages are a great fit for this environment of multi-component, complex cloud applications of today and the future. Now, if you want to learn more, there is one link that you have to like make a screenshot of, or just remember. If you go to that link, you'll get to a Git on GitHub, which has the slides, all the websites, my Twitter account, and then some examples, some extra videos, and so on and so forth. So you can just go there and click through, explore more at your convenience. And it's tuned for .NET developers, so it's only .NET content here. So that's the end of my presentation. I'm not sure how I did with timing, but I can answer any questions now or like later during the chat at the bar.